Hi guys, welcome to my channel again, and today I'd like to cover the topic for inverse functions. It's another pretty important topics, and before I'm talking about these inverse functions, we have to revise the definition of what is function, okay, in our math concept, okay. Function basically means a relation, okay, and we define it's only these two types of relations. They are functions, okay? So many to one and one to one. So the example here is y equal x squared and y equal x, okay? But then for inverse functions, we only keep saying or keep emphasizing that only one-to-one function have the inverse. Why this is the case, okay? Let's just think about this. Why only one-to-one function have the inverse function? So what we do is for inverse function, typically is we just change x and y. So we xy change to y and x. Makes sense? This is actually the inverse, okay? We substitute x into y, y into x. So basically means we do the reflection, okay, around the line symmetry y equal x, okay? So let's, for example, y equal x squared, and we do this, switch things, so we got x equal y squared. So what's the graph for x equals y squared? So it becomes like this, okay? This is y is x equals y squared. So for this one, it's no longer a function for previous definition. Why? Because if we use the vertical line test, we know one x value, we have two y values, right? So this is 1x, we got y1 and y2 corresponding. So in this case, it become one to many, this relation. But this relation, according to our definition, is not the function. That's why the many to one function never have the inverse functions only if we restricted the domain. Okay, we only take part of the functions. For example, we got x, y over here. I got this one is y equal x squared, but I could only take either the left side or either the right side or the left hand side. So if I only take this one, which means comma x is 0 to infinity, or I give the official way f 0 to infinity r x equal x squared. In such case, it has inverse because it's only part of the original function and it becomes one-to-one now. Okay, so that's the inverse function basic ideas, and you need to remember because we practice for the final year exam. So we have three properties we have to remember. First one is the fx and its inverse function is symmetry, or we call it reflect in the line y equal x. Okay, reflect about this line. And the second property is domain and range. So second one is fx domain is inverse functions range. Okay, the third one is the range of fx is the domain of f inverse x. Okay, because what we do is xy change to yx. Then our DOM stand for domain becomes the range over here, and our range over here becomes domain over here. Okay, so but vice versa. That's why we have this one over here. Okay, let's move on to the examples. Now it's like, how do we really solve the inverse functions? My suggestion is just use the method 1. Okay, this one is easier to understand. So always the first step is switch, or let's say change. Okay, switch between between x and y. Okay, I read this one. Switch between x and y. Okay, and second one is make y be the subject again. The last part is state the domain and range if required. Okay, but at least state the domain for the new functions. Okay, but just make sure you know how to solve or how to make the y be the subject again. Okay, this is a bit tricky part, but after practice you guys can get it. Okay, let's try one. For example, we take this one. Okay, this is gx equals 1 over 5 minus x and x greater than 5. Okay, so which means original function is y equal 1 over 5 minus x. And first step, switch xy, so x equals 1 over 5 minus y. And second step is solving for y, so make y be the subject. So for this one, with both sides times 5 minus y becomes x equals 1. Then open the brackets, become 5x minus y times x equals 1. Then 5x minus 1 equals y times x. So our y gonna be 5x minus 1 over x. So if we write one more step, it's 5 minus 1 over x. Okay, this is the relation, and this is the inverse function. But just remember, our original domain is x greater than 5, so our original range is -infinity to 0. Okay, so for my next part, this one, the domain gonna be -infinity to 0 as well. Okay, so let's look at here is -infinity to 0. Okay, and let's look at another question. Now the next one is like graphing the inverse functions. So how do we redo the graph? This is pretty easy because we switch the x and y. And this is read as the ordered pair xy is mapped to the ordered pair yx. So for every single term, okay, let's, for example, is the original point is 1 and 2, so you switch to 2 and y, which means the ordered pair 1, 2 is mapped to the ordered pair 2, 1. Okay, so it's like this one over here doing the reflection. Okay, so let's keep going. First one, find the inverse functions and sketch the both functions on the showing the points of intersection of the graph. Okay, this is the typical exam questions. The typical means it always let us to find the intersection between two graphs, which means fx equals f inverse x. Okay, sometimes exam 1 can ask us to find this intersection. You're gonna say it's not that hard because we just make both equal and we solve it. But sometimes we need some the tricky part to help us to do it quickly and easily. Okay, so let's look at this one, and I will emphasize this trick part. Let's look at the note over here. So before I look at notes, make sure you guys go through the exam 25, then you know what I'm talking about. So from the example 25, okay, if we look at the coordinates for these two intersection point, then we realize something. For this point, the x, y, and xy, they are equal to each other, right? So, which means the intersection is on the line y equal x. Y equal x line gives us some property is the x coordinates always be the y coordinates. Okay, that's why if we want to find the point of intersections, we always can use this part. So fx equal x or f inverse x equal x. So instead of solving this one, we can do this. Okay, f inverse x equals x. We can do this. So it reduces a lot of calculations and save us a lot of time. Okay, but however, it's not all of the graphs have the intersection on the y equals x. Okay, sometimes it might be on this line as well. This line is y equals negative x. Okay, or even y equals negative x plus k. So if the graph is look like this, okay. So sometimes it's a bit tricky, but for most of our case until now, I mean 2019 final exam, if in exam 1, the examiner just to test you guys to find the intersection of fx and its inverse, it always want you guys to use this trick, okay, to find the value, always. So just keep remembering this one, and sometimes you can draw the graph to help you to understand this concept. Okay, this is on the page 35. Okay, and this note is pretty important. Okay, and now let's do this part. So first we find the inverse of the function and sketch for the both functions. Let's find the inverse first. So y equals 3 to the times square root x plus 2 plus 4. Switch x and y. X equals 3 square root y plus 2 plus 4. So become x minus 4 divided by 3 and equals square root y plus 2 and x minus 4 over 3 square equals y plus 2. So y equals x minus 4 over 3, the whole thing square minus 2. Okay, this is the case. But just if I change this question a little bit, the second question is ask you to find fx equals f inverse x. And without cast, if we use our old method, become x minus 4 over 3 square minus 2 equals 3 square root of x plus 2 plus 4. Okay, then you realize if we square at both sides to get rid of this square root, we got the fourth. Okay, x to the power 4, which means technically we cannot solve it by hand. Okay, that's why we need to involve with another equation. This one equals to x. So either you do x minus 4 over 3 square minus 2 equal x, or just use 3 times square root of x plus 2 plus 4 equals x. Okay, both way is fine. And from the graph, we can clearly see that this intersection again is lies on y equals x. That's why we can use this method to help us to solve the problems. Okay, and that's it. That is for today's topic, and hopefully you guys notice and the importance of the inverse function, and my explanation helps you to solve the inverse function inverse function properly. And for all my next videos, again, I'm gonna do some final exam questions about inverse functions and use some strategies I covered in these short videos. Okay, hope you guys like the math, and if you like my videos, please click subscribe and click the like button. Okay, see you guys next videos. Bye bye.